Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETAS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETAS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Hello, my name is Mark. Thanks for listening in today's podcast episode. I'm the product manager for the cybersecurity consulting service at ETAS. I'm located in Munich, Germany. And that brings us to today's topic in this episode. We want to speak a little bit about the current standards current status when it comes to standards and regulations. Two of the most prominent ones are the UN Regulation 155, which is relevant for the type approval. So in the contracting countries, an OEM needs to get a type approval according to the UNR 155, and the countries have to implement it into national laws. And the related ISO 2144 is describing the activities that needs to be done. And yeah, I'm very happy that today I don't need to speak alone on this topic. I have invited two of my colleagues. The first one is Joseph from our location in Paris. Joseph, great to have you on the show.
Yeah, thank you. Thank you for having me. So maybe I can give a quick introduction. So I'm a cybersecurity consultant with the ETAS France team for about a year and a half now. Working on in the automotive cybersecurity scene for about 6 years, right? So on this subject, I've participated in the automotive cybersecurity regulations working group. So where they draft these regulations, and now I'm helping automotive companies apply these regulations by putting in place cybersecurity management and software update engineering.
Yeah, thanks for joining today. To get an even more international experience in this episode, I have also invited Chris from our location in Detroit. Hi, Chris.
Thanks, Mark. Yes, Chris Lupini, a member of the cybersecurity embedded consulting and pen test team for North America, based out of Plymouth, Michigan, except that I work remote from Indiana from my home office. I've been with ETAS only about 7 months, but have 33 years of automotive electronics experience and just about 10 in embedded product cybersecurity, mostly in building up a cybersecurity core team to develop a cybersecurity management system and pen testing, and especially interested in governance, risk management, and compliance. So I've been participating in ISO and SAE standards developments for many years. Also, a lot of activity with the Auto ISAC. I'll talk about that a little bit more later. But yeah, glad to be here.
Yeah, thanks for joining. Great to have someone with that level of experience in here. You mentioned already some other activities, Auto ISAC, SAE. I know there's many other frameworks in the market. Joseph, I know you do a lot of audits. Can you maybe give some insights what frameworks you came across in your projects?
Yeah, so in a lot of our audits where we were using the NIST cybersecurity framework. Yeah, I like this framework quite nice. There's also a new revision coming out, so we should keep an eye on that. I also used for CSMS and SIMS the our proof framework, which is also a nice tool. Yeah, built in-house.
Okay, interesting. So the NIST is more for IT security, right?
Yeah. It was the NIST. We were using it for the production, yeah, and IT and OT security. But yeah, the proof we were using proof when we were focusing on the product side.
Okay, because I currently have a project where I develop the CSMS according to ISO 2144, but at the same time also automotive spice for cybersecurity. So in this project, we consider two frameworks in parallel. And last year, I performed an audit where I used the VDA automotive CSMS questionnaire. So this one is another one. So yeah, uh, quite interesting that there's so many different frameworks in the market and also different ones that we use.
Yeah,
Um,
that's the nice thing in proof, right? Because we integrate all of these in the same framework.
yeah, true. In my project, I always use the proof model, so that helps a lot. Before I joined ETAS, I was working in the embedded electronic control unit development, and also there I tried to convince my colleagues, for example, from software hardware development, to use and implement international norms and standards. Sometimes I got the feedback, they said, why do we have to do this? This is just paperwork and this doesn't really make the product any better. So we just have to do it because of the process. What's your opinion on that? Do these frameworks really help to improve the product, or is it just paperwork?
Yeah, that's a question that is really trending, especially since in the automotive industry we're seeing these relatively new regulations that enforce cybersecurity and with the potential for a lot of investment in the sector. And yeah, people are asking, why do we need this? How can this help us? But it can and it does help a lot, right? So especially lately we've seen in uptick in cyber attacks in the automotive industry, like have you heard of the last cyber attack on the production lines of a big Japanese OEM, where they had to halt all of the production in a lot of production facilities? That was a big attack. Yeah, I've always wondered. I mean, these attacks, they are infiltrating the networks and uh, and they are halting. And when an attacker in the network halting the production is maybe the better outcome, or or the least risk outcome. And there are regulations that cover this risk. But I personally wonder, I mean, if we're already in the network, we can do much more damage, right? If an attacker, for instance, injects one piece of code or chain modifies one piece of code that is flashed on a component and eventually goes into vehicles, this attack could have much more devastating consequences, right? We can do damage to the safety or operation of a whole fleet of vehicles. And this is
Mm.
what the regulation that you mentioned, the R155, is actually trying to prevent. We want the security of the product. We want to ensure that the product remains secure even when we're attacking the production lines, etc., right? Because halting the production, that would cause some financial damages. But if we're attacking the product, then there's a safety risk, there's real lives at hand.
There's also one famous attack recently, a very young German guy with maybe self-taught knowledge. He attacked a quite famous American electric car manufacturer. Chris, what would you say is the status regarding ISO 2144 implementation in the United States? How would you say, where are the OEMs and suppliers?
Yeah, I've noticed in the past couple of years, especially since the final international standard version of it came out, that pretty much everyone is adopting it de facto, the same as we used to do with pollution rules. California might have the most stringent, but the manufacturers build to that highest standard, so they can, they don't have to have two different car types there. So I know there's quite a few OEMs that already have certification to R155, which is geared toward their level, which infers that you really need to use a framework like 21434 at the supplier level. And the tier ones I've worked with are all going after their certification or already have it. So that's just become the way of doing business. That they're all building it in today. I think people know that with R155 that kicked in July of 2022 for new vehicle types in the European Union and other countries that adopted it. The United States was not one, but since the automakers sell all over the world, it just makes sense to include it. So you don't have to have different models. In the U.S., we are self-type approval, so that's a little bit different than in other countries. So things are different, but having a common regulations, it makes it easier. And our 155 then will become applicable for all vehicle types beginning in July of 2024. So things move rapidly. Time goes by quickly, and the world is starting on a new edition of ISO SAE 21434. So that's getting started. I wanted to say a little bit about that it is going to be a long project. Probably won't actually kick off officially until 2024. It takes a while to get things going. There's some items that have to be developed that are mainly in the appendices right now for 21434, like cybersecurity assurance level, targeted attack feasibility, verification and validation. There are SAE and ISO committees meeting weekly or biweekly right now to get that straightened out before the actual team of developers will begin probably next year. There is a meeting scheduled for near Seoul in South Korea in October, where what's called the Joint Working Group between ISO and SAE, the members will get together and see what it's going to take, and hopefully set the timeline for when the next edition will come out. And it's intended to be written a little bit more agile oriented than the current waterfall look to 21434 right now. But the V model of design and going into test that we've used for years and years is still applicable, but it just needs to be done in more of an iterative model. So the cybersecurity requirements and work products, templates that have to be used in design are always in refinement all throughout the product design and over its life cycle.
And so you and me, we are, besides the ISO activities, we are also part of the SAE Cyber Maturity Model Task Force. Can you explain a little bit what's happening there? What's the target there?
Sure, yeah. It's intended to be an SAE-J standard eventually. I'm not exactly sure the timeline. It hasn't been set, but probably another year. That's going to be SAE-J 3254 maturity model, which looks like it's going to be more of like a comparison of maturity models that are out there. ASPICE, BSIM, building security and maturity model, and ETAS's proof tool to see what the differences are, advantages, disadvantages. And for the maturity model, it's to basically be able to compare your suitability to 21434. So it's more of a survey document that's being worked, but it is important because we have to have a way of checking our cybersecurity management systems to see if they do conform to 21434 or other frameworks like NIST, or there's one from NHTSA, National Highway Transportation Safety Administration. Transport Canada has one, their vehicle cybersecurity strategy that's mainly for government use. And there's even the ISAC best practice guides that are being rewritten right now, but cover all sorts of topics across the secure design lifecycle that we do for embedded products.
Okay, so yeah, quite a long list of organizations and frameworks that are out in the market speaking about similar topics. When we come to project, when we help customers implement, or when OEMs or suppliers are implementing a cybersecurity management system, what would you say are the biggest challenges, Joseph, within the framework? Like which topic would you say is the biggest challenge?
Yeah, what I've seen is that, I mean, when companies hear of the cybersecurity, we always think of classical IT cybersecurity, and where companies are really generally good at that, but then the struggle is more on the product side, right? There's, in my opinion, some severe lack of skilled personnel for this type of tasks, and we couple that with the time constraints and the resources constraint on a product that need to be delivered, and the sense of urgency that we need to validate requirements from for the product. So this is really the main issues with where we see with the client. And this is where we come in, like we ETAS, because uh, we help the client on the governance side, but we can also help on the product side, right? So yeah,
Mm.
I see things getting better now, a little bit slowly but surely. I don't know if you've noticed this, Chris or Mark, if you've noticed this, that right over the past couple of years, I have seen some really good improvement or an increase in maturity in the whole industry, actually.
For me, it's quite funny. I see very different level in maturity. I see some OEMs, maybe large international OEMs, they are really mature, have whole teams taking care of cyber security. But I also see maybe smaller supplier, they are just about to start. So it's quite interesting how maybe different the level is. And I think that's the big advantage also from those standards and frameworks, that you establish a common way of speaking about topics and a common way of doing things. So when you speak to each other, when suppliers work with customers, they already have a similar, yeah, they have similar terms, but also similar methods that they use. For example, Tara method for risk analysis is somewhat standardized, so you can rely on that the level someone is analyzing his product is equal to your own level. And the same way that you have a maturity model, so you not only say, okay, you do risk analysis or you don't, but you do it in a, yeah, certain maturity.
Yeah, that's a really an interesting point, because I've seen this firsthand with a couple of our clients actually transitioning between OEM specific language to the ISO standard language, right? This is a really nice topic that you brought up, because we've seen it firsthand, and it makes a lot of sense, because now everyone's speaking the same language and we can understand. Oh, yeah.
Mm. What I find challenging in my project is, for example, cybersecurity monitoring. So I believe it's easy to monitor a network from an IT enterprise infrastructure, because you have direct access to it. But to monitor a vehicle that you don't have direct access to it, maybe we are the cloud, but yeah. So I think that's also quite a challenge. Joseph, in your introduction, you brought up the topic of SUMS. Can you explain to me what is SUMS and how does it interact with cybersecurity?
Yeah, this software update engineering, right? Yeah, so this is based on the regulation R156, which is drafted in the same by the same team that's doing R155, and yeah, this there this is really interesting regulation because of the reasons why do we have it. Uh, yeah, there's a couple of reasons why. The first one is that we can actually do a lot of things by software in the vehicle now. Like, have you seen the subscription models that OEMs are proposing now? The subscription for vehicle functions. Have you heard of that?
No, I haven't. Can you explain a little bit?
Yeah, so I've seen subscriptions for things like heated seats, or like you can do a subscription and add more power to the engine, or some unlock max speeds.
Ah, you mean like function on
Yeah,
demand?
yeah, yeah. Yeah,
Yeah, yeah.
so
Okay.
these, I mean, this means that now we can do a lot of things to the vehicle remotely, right? So through an update, and these changes. I mean, if let's say we change the max speed of the vehicle, now suddenly we can produce more pollution, right? Or increase the sound levels, right? Which have some environmental impact. Or maybe we can change the driving mode, which would affect
Mm.
the safety functionality. Right? So yeah, but this is now an issue because these functionalities are type approved. They are by type approved. Yeah, I mean certified in most countries. I mean not in the U.S. because in the U.S. there are regulations, but self-enforced, but they're still regulations. But the issue is if these functionalities are certified, now how would the authorities um, know which certified software is installed on the vehicle? How would they verify that the software is certified, right? And so this is the first need. The need is the authorities need a way to know which certified software is installed on the road, right? So this is why the
Mm.
regulation proposes this RxWin. Have you heard of it?
Yeah,
Do you know what it stands for?
but software identity is
Yeah.
something.
So yeah, the software identification number part is the identification for the software, but RX means regulation X, right? So the UNECE regulations. There's numbers for each category, right? For each regulation. I mean, the cybersecurity regulation is R155. The software update is R156. It's UN regulation number R1156 from the WP29, right? So sound levels, for instance, is R51, and tire pressures is R141. So if we have a software um, now that would affect sound levels, so for instance, if we increase engine power and now the software would affect the sound levels, it would need to have an identifier R51 win. So the X stands for the regulation number, right?
I
Yeah.
see. And then the ID helps to identify the correct software and the correct control unit.
The ID is defined by the vehicle manufacturer with information relevant to the type approved software, right? So there is some information proposed in the regulation, and the idea is now the authorities can connect to the OBD port and read this identifier, and now they know which type approved software relating to sound levels is installed on the vehicle.
Mm. And what is the connection between the cybersecurity management system and the software update management
So
system?
there is no management still here. Here the first reason, so the RX Win is only part of this regulation, but how does it relate to cybersecurity? It's because now it's important that this RX Win should not be tampered with, right? It should be we should I mean there is regulations related to it, and the authorities need to verify it, so it shouldn't be possible for anyone to just modify it or tamper with it. So this is where cybersecurity comes in for this requirement, because now the OEMs need to implement security measures to protect this this identifier, and they have to also prove to the authorities that we have protected. So there is so this is where cybersecurity comes in, but the management.
And probably not only to protect the identifier, but to also to protect the whole software update package,
Yeah,
right?
I mean, this is the second reason we have 156 actually, because we now have real ease at which we update our vehicle, right? Now, a couple of years ago, we would need to go to the shop and like plug in, ask a certified expert to update our vehicle, and then wait in the shop, and if the update operation would be supervised, right? But now we just receive the update package like we're on the phone, right? But this is not a phone. This is a vehicle, right? And this is, I mean, on the phone, what's the worst thing that can happen if we have a bad update? We can lose some access to some accounts or data. But on a car, imagine you're cruising down the autobahn at 200 and then your car suddenly reboots, right? That would not be fun. So yeah, so the regulation proposes measures to increase the safety and the security of this update process. So, yeah, so how do we do it? We need to inform the user of that the update will be made. We also need to tell them how much it will take, like how much time. There is, I mean, imagine you're late for work and you tell your boss, yeah, it's updates again. I had to update my car, right? Yeah. So yeah, we also need to make sure the vehicle is in the correct conditions and has resources and is actually compatible because with the update, because now it's like it's safety relevant, it's important. Yeah. So how does this relate to cybersecurity? It's because, yeah, as you said, this process also needs to be secured. Like we shouldn't, the update package, we shouldn't be able to tamper with them. The delivery infrastructure need to be secured, and this is relates to by SMS mostly. The software update development need to be validated safely, and this relates to the CSMS and the development process. And this is where we mostly have an overlap with R155, and actually R155 in the Annex 5 there is a specific section related to software updates. There is a tie, yeah. So there is a link between R155 and R156 in this regard.
Okay, yeah, quite a challenging topic. So maybe to wrap it up a little bit, what we see is many different frameworks in the market. Some end up in laws, some are defining basically the state of the art. Yeah, some customers are already quite mature, some are still in the middle of implementing. We have to keep the software update systems in mind. Today we didn't speak about Asia, so we didn't think about what's happening in China. I know there's a lot of activities going on with the GBs and GBTs. Korea, I think, is working on a own legislation based on the current guideline. India is developing two new standards, I think similar to 155 and 156. And in Japan, we have several activities. So I believe in the next episode, we should maybe invite our colleagues from Asia and see what's new there. But for today, Chris, Joseph, thanks a lot for giving your insights on the topic. Any final remarks from your side?
Certainly, yeah. I wanted to thank you for having me on this discussion and remind everyone that cybersecurity in vehicles is an extremely important topic, mostly because of safety, but also because the car makers do not want recalls if something goes wrong. We remember the G pack, that was billions of dollars it cost the company, and you can lose brand reputation, lose customers. So these regulations and standards help keep things, they put guardrails, as we say, on how we do our designs and have safe vehicles out there. So it's a lot of challenges to come. We haven't talked about a couple of major things that we have to get through, like long-term maintenance and continual updates to the software for many decades potentially that the automakers will require. So having the right tools and techniques, including like the proof or other maturity models, makes it easier and simpler for your engineers to design products, because we are short of cybersecurity engineers worldwide. So giving them proper tools and assistance makes the job easier, and so we can get this right.
Great, yeah. From my point, nothing more to add. I think nothing more to say. So thanks a lot, both of you. And this concludes our episode on insights on automotive cybersecurity standards and frameworks. Thanks for listening.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.